classification of signal. So I have already discussed, one is continuous time signal and discrete time signal. Then already I have discussed analog signal and digital signal. Today we will learn about what is called a real signal and complex signal. So today we will discuss about a real signal and complex signal. So real signal means which contains values or parameter only real numbers. Okay, there will be no j term or I term. Okay, only real part will be there in the signal. There will be no j or I term. So you can say like that. Definition you can write like this: real signal takes values belonging to set of real number. Okay, it only take the values which are real. Okay, real numbers. So you can write like one formula, or it should be satisfy what condition, that is it should satisfy the following condition. Okay. What is the condition? X of t should be equal to x of star t. So what is meant by x star? X star is nothing but it is a conjugate of the signal. Conjugate of xt. You, I think, know what is called conjugate. Something, suppose a value a equal to given a plus ib or jb. When you take a star or conjugate, then it will be a minus ib. Understood? So real signal should satisfy xt equal to x star t. Means there will be no difference. Okay, because we already know if we suppose a equal to 2 is a real number. When we take a star, then it will be 2 only. Okay, so this real signal should satisfy the condition xt equal to x star t. So then come to the complex signal. It's over. Have you taken the note? Complex signal. What is called complex signal then? It takes, okay, it takes, or you can say, okay, it takes, or it consists of, you can write, it takes values belonging to a set of complex number. Belonging to the complex number, and it should satisfy the condition should satisfy the condition that x of t not equal to x of star t. because the sign would be changed for the imaginary part. That's why when we take a star, then the xt will not equal to x star t in case of complex signal. Okay, so let me give one example here. Okay, for real signal, the example would be like sine twice pi ft, or you can say e to the power twice t or at like t. Okay, so there will be no j term. These are the example of etc. Okay, these are the example of real signal: sine twice pi ft, e to the power twice t or t, etc. Okay, then what will be the example for complex signal? Like you can say e to the power j omega t. Here j term will be there. Okay, or you can say cos omega t plus j sin omega t. And new j term is there. Since if there is j term, then those signals are called complex signal. Okay, I think you have taken the note. So if you have any doubt, you can ask. Come to the another types of classification, that is the fourth. Four types of classification is called deterministic, signal, and random signal. Random signal also known as non-deterministic signal. Okay. So what is deterministic signal? So you can write like this: a signal is said to be deterministic deterministic means we can define. Okay, we can determine like this. The name has come. Determined means we can assume the amplitude values after 100 seconds or 200 seconds. Okay, let me when I give the example, I will give you the concepts why this name has come, deterministic. Okay, a signal is said to be deterministic if there is no uncertainty. Okay, uncertainty. There is no uncertainty with respect to its value. At any instant of time. At any instant of time. What do you mean? So what types of signal are deterministic? Like, let me give one example, that is unity step signal. Okay, this is the one example of deterministic signal. Why it is called deterministic? Because we know the amplitude at 0. What is the amplitude? 1. We know at t equal to 10 second what is the amplitude. We also know what is the amplitude for t equal to 100 second. Okay, 1 only. Or you can say what is the amplitude of unity step signal for 1000 seconds or 5000 seconds or 10,000 seconds. We know. Okay, there is no uncertainty. There is no uncertainty about the amplitude. We know the amplitude is fixed 1 for any time instant. Okay, so deterministic signal, you can say it can derive in mathematical formula, or we can give some functional representation. So deterministic signal can be expressed in numerical mathematical formula also. You can say like that also. Okay, there is no uncertainty with respect to its time. Okay, at any times we can assume, okay, what will be the signal amplitude. Okay, so you can write like this: a deterministic signal, all the signals which can be represented with the functional representation are falls under deterministic signal. Deterministic signal can be represented. So you can write like this: can be represented or defined exactly with mathematical formulas. Understood? Deterministic signals formula or okay. Deterministic signals are those signals which we can defined with a mathematical formula, or you can say then we can determine the signal after or for any instant of time. We can say, okay, that's why it is called deterministic signal. Then what is random signal? One minute. Class here, can you give the attendance? Madam has come to take the attendance. Nowadays, system has changed. Okay, to take attendance, every day Madam will come and you will take the attendance. So, can you give the attendance? Class here. There's the register copy. So, can you give who are the absentees? 39. Class here, are you there? Or anybody, can you give the absentees? Who are the absentees? I have to write now.
Okay, sir, I will give.
Now it's required. Madam is waiting. Second year A. Total 25 is absent, no? 64 is there. 64 24 and 1 is 25. Yes, sir, 2 minutes. Give the absentees number because I have to write in the register. There will be 25 candidate, I think.
Can I say?
Who is this? Somebody mic is on. Please mute your mic. Please take the note. If you have any doubt, you can ask. In the meantime, sir, I will text you in the WhatsApp. I will. Okay, give it. Okay, it's a required because Just give the attendance soon. You have given the attendance. Can you give the absentees? Who are the absent? Open. It will take time for me to find out who are the absentees.
Sir, should I read out the absentees or should I text you in WhatsApp?
You can read out. No problem.
Sir, 201 is absent.
201,
204,
204,
207,
07,
209,
209,
217,
217,
219,
219,
226, 27,
26, 27,
32.
232.
Yes, sir, 232. Two 32.
232 I written already.
And 234,
234,
Sir, can you
238,
please check?
who is this?
Pravalika, sir, 203, girls here.
Yeah, 230,
8.
238 absent.
Yes,
Yes,
sir,
sir.
238 absent.
Okay, next.
41,
241,
42,
242.
43.
243, okay.
Hello.
Yes. Yeah, you speak.
Okay.
Yes.
Sir, 241, 242 and 243.
Yeah, I have written.
240, 248
48,
and 251, sir.
251. 16 is there.
Yes, sir, that's it.
I think 4 more, because there is how many present? 39 and 40 present, no? 64 student.
Sir, I think some people are related to detained candidates, sir. Pranav, 255, Pranav.
255 is present, I think.
No, sir, just a second. Pranav,
Yeah.
Pranav, Revan, Hari. Yeah, Pranav, could you please give attendance of detained candidates? I don't know the roll numbers. Could you please help me in that?
Okay, 1 minute.
Hello,
Yeah.
sir.
Yes.
Sir, I have already sent it, sir. Absentees of today's class. Can you please check it in your WhatsApp?
Two A1 is absent, no? 2A1, 242, I think written. I have written, yeah. 2A1, 21, I have written. No. 2A1 is absent, 218 is absent, 252 is absent, 255 is present, right? 296 is absent. 296 is from A section or B section? 2A4 is absent, 2B0 is absent, 2B2.
Sir,
296. Yeah.
2B0, 2B2, 2A1, 242, and 218.
I have written.
That's it, sir.
Okay then. Total. Okay, come to the class. Okay. So we are discussing random signal, deterministic signal, and random signal. Okay, deterministic signal are those signal which we can determine with some equation. Okay, which we can assume or we can say what is the value after for some instant of time. Suppose for 100 second or 5000 second, what will be the amplitude? We can say. Okay, but random signal we cannot say that. There is some uncertainty. So you can write the definition like that. A signal is said to be random signal if there is uncertainty. Okay, previous definition there is no uncertainty, but in random signal there has some uncertainty. There is uncertainty with respect to its value. At some instant of time. Okay. So what is those signal means? A signal here which is random signal, but when it is called random signal, when there is some uncertainty, okay, which summates instant of time. Suppose we have to draw a signal with respect to tossing the coins, okay. When you coins one time, what will be the output? 8 or 10. When you toss for 100 times, what will be the output? We cannot say previously, or we cannot give some mathematical formula to the experiment like this, like toss the coins or in dice. Okay, so example like coin toss experiment. Okay, or you can say noise signal. All the noise signal we cannot define, or we cannot give mathematical equation to the noise signal. So these are from a random signal and a deterministic signal. So let's go for the even and odd signal. So I think fifth number classification is even signal and odd signal. Okay. This is very important topic. So what is called even signal or what is called odd signal? So one relation is there, that is xt should satisfy with x of minus t. So you can define like this: a signal is said to be even when it satisfies the condition it is x of t equal to x of minus t. Okay. This is you can say for all time t. Okay. So you should understand the things. What is it is said to which signal are said to be even signal. Let me give one example. Okay. Like even signals are cos omega t. Okay. Like cos t, or you can say t square, or you can say t4. Okay. These are the even signal. Okay. How it is even signal? Let me start from t square. Okay. Suppose xt, let me prove, suppose xt equal to t square. Okay. So what will be the value for x of minus t? What will be the for minus t? When we give minus t, then we have to put minus t here also square. What will be the value? T square only. So from 1 and 2, from this two equation, we can say that x of t equal to x of minus t. That's why xt equal to t square or t4 are all are even signal. The power of even, okay, are called even signal. So how I can prove the cos signal as a even signal? Okay. How we can prove? Like that, let me give. We know the definition that cos minus theta equal to cos theta itself. Okay. So let me give the example. Okay. Suppose xt equal to cos t. Okay. So we know that cos of if we put x of minus t, then it will be cos minus t. So now we know that already cos of minus theta equal to cos theta only. That's why x of t equal to x of minus t. Somebody may ask, sir, how that cos minus t is a cos t itself? So can anybody explain what is cos minus t equal to cos t? How we can relate that? From where that concept can be say cos minus t equal to cos theta itself. Okay, let me give the concept. If quadrant, okay, all means sine, cos, tan, cot, cosec, sec are all are in positive here. Okay. But second quadrant, what is the what values will be positive only? Can you say? Only sine time. Okay. Sine and cosec. Okay. These two trigonometric signal give some positive values. Okay. Here tan and cot. In this here cos and sec. Okay. When suppose something previously is theta is some cos t is given. Okay. But when you take minus t, it will come to the fourth quadrant. Fourth quadrant means there is only positive term, means cos term only. So it gives the positive values. That's why it's say that cos minus theta equal to cos theta itself. Do you have any doubt? Okay, let me visualize that. Let me give. Let me make you clear with another example. Okay. Why this cos minus t or what is even signal? You can now you can visualize the things. What is called even signal? If you plot the cos theta, okay. Suppose cos t. This is the signal of cos t. Cos t is start from y-axis. Okay. Now you come for any time instant t equal to suppose here suppose 2. Okay. For t equal to 2, what is the value? What is the value? Because we are dealing with the inside of the bracket. So t equal to 2. Suppose here value is 0.7. Okay. Suppose the 0.7. Okay. What is the value for t equal to minus 2? Because we have to see this minus 2 deal with the minus t. So we'll take minus 2. Okay. What is the value of minus 2? That also what will get 0.7 only. And what we'll get? We'll get the positive value itself. That's why we can say a cos signal is a even signal. Okay. Because it's a proof that x of 2 equal to x of minus 2. Understood the things? Okay, then let's go for the odd signal. What is called odd signal? It should satisfy, a signal is said to be odd when it's satisfied the condition x of t equal to minus x of minus t for all time, for all t value. The examples are, what are the examples? Sin t, t cube, etc. Okay.